Good day, everyone. For this video, we're going to talk about the derivatives of trigonometric functions, and there are 6 of them that you need to know. So, let's get started. So, let's start with the first derivative. The derivative of sine x is cosine x, and the derivative of cosine x is negative sine x. Now, look for the pattern as I type the trigonometric functions. The derivative of tangent is secant squared. The derivative of cotangent, the cofunction of tangent is cosecant squared, but with a negative sign. The derivative of cosecant, that's equal to secant x and tangent x. The derivative of cosecant x is negative cosecant x cotangent x. So, notice that the derivative for every cofunction, particularly those start with letter C, they all have negative sign, and notice that the similarity between tan and cotan, the derivative of tangent, is secant squared. The derivative of cotan is negative cosecant squared, and secant and cosecant are similar to the derivative of secant and secant tan. And the derivative of cosecant and negative cosecant, cotangent. So, some of similarities here, if you know the left side, you can easily figure out what's going on to the right side of the screen and the left side of the screen and their difference of their sign. Now, let's get to the example that reported by Joshua Dimas.
Thank you, Mr. Jericho Nava. So now let's go ahead and try some examples about the derivatives of trigonometric functions. So for the first example, we are going to find the derivative of 5 sine x minus 4 tangent of x. We will first write it as 5, the derivative of sine x minus 4, the derivative of tangent x. So based on the derivatives of trigonometric function, these two trigonometric function, which is the sine x, will be converted to cos sine of x. That will be the derivative of sine x. While the tangent of x will be equal to secant squared x, which is the derivative of tangent of x. So after that, we are going to bring down this two whole number, which is 5. Added the cos sine of x minus 4 secant squared x. That is the final answer for the first question. So now for another example, we will going to find the derivative of 8 secant of x minus 5 cos secant of x. We will write it also as 5, the derivative of secant x minus 5, the derivative of cos sine of x over dx. So based on the derivative of these two trigonometric function, the secant x will be equal to secant x tangent of x, while this cos secant x will be equal to negative sine x. So after that, we will going to bring down these two whole numbers, which is the 8. Added this trigonometric function secant of x and tangent of x. So based on the rule of mathematics, when two negatives are multiplied by each other, it will be going to become as positive. So after that, bring down this negative sine x, or will be equal to sine x, and 5. So that's the final answer.
Okay, for our next example, we have y is equals to x squared raised and multiplied by sine x, As for this problem, we can use the product rule, in which it would look like f multiplied by g prime is equals to f prime multiply by g plus f multiply by g prime, on which our f is assigned to x squared. That would be x squared. And then our f prime would be 2x, following our power rule, in which it would be nx n minus 1. And then for our g, it would be sine x, and our g prime would be cosine x. Now moving on to our formula, we can plot this as y is equals to, let's move it to down here. Y is equals to our f prime, which is 2x, multiply with our g, which is sine x, plus, you can also add some brackets here, multiply it by our f, which is x squared, and then finally multiply it by our g prime, which is cosine x. And our final answer would look like y is equals to 2x sine x plus x squared multiplied by our cosine x. And that would be our final answer.